This video is about the steady rest I made for my GoPro. So there's a lot of examples of homemade steady rests on YouTube, and I encourage you to go check them out. You know, just search them out and watch them, and that's what I did. And I found a design that I liked, and I've just kind of duplicated that, throwing my own spin on it. There's, you know, just some subtle differences based on what I had at hand and what I could get my hands on and when I could get my hands on them. So this is my interpretation of a steady rest, and I'll at the end of this video I'll post a couple of test shots that I made with my Panasonic camera this afternoon. But what I have here is some skateboard wheel bearings. I've got 5 of them here. You don't need 5, you really only need 1, 2 at the most. But I've got them. I got all 5 here because they fit nicely on the bolt that I have. And to be quite honest, I've had this skateboard laying around since 1987. And you know, does it look like I skateboard anymore? And if I don't use these bearings, they're going to sit in my toolbox till, you know, 2050 or whenever I die, whichever comes first. So I might as well just use them up. So I got the wheel bearings for the skateboard. I've got the spacers that go between the bearings on the skateboard wheels, and would be a bearing on the outside, bearing on the inside with a spacer between them. And those are on a bolt, like so. You just alternate bearing and spacer. Now at this point, you could put whatever swivel or gimbal you had on the end of that and be done with it. But I wanted to be able to have a handle that went around this. I could use the bearings as a handle, I suppose, but you know, the design I saw used PVC that was hogged out from 3/4 inch diameter on the inside to 7/8 to house the bearings. And that's probably the most expensive part of this build, was buying the drill bit to do that. And I used an auger bit because that's the only bit that I could find that was long enough at Home Depot. But outside of a spade bit, there wasn't a snowball's chance in Hades that I was going to use a spade bit with this in my hand and a power drill in my other hand. So, and the auger bit wasn't a very good idea, but it worked in a pinch. But I wanted to have and I've got enough of this garbage laying around that, you know, I had the stainless steel specialty washer that's beveled and it's machined to accept a taper head bolt. And I thought, well, that would be nice for a thumb screw to steer the camera on the vertical axis, whatever. So I put this thing together like that, and when I put the gimbal on it, I realized that it was making contact. This big washer was making contact with the outer race of the bearing and preventing the top bearing from spinning, which kind of rendered the whole thing useless. So I needed to have something to put in here to bear on the inner race, and all I used was an O-ring, and that serves a couple of purposes. First of all, it keeps the specialty washer here up off the outer race and keeps that pressure bearing on the inner race, and it provides just enough cushion where I don't actually have to torque this thing down to keep it tight. Finger tight is tight enough. And then I just use for the gimbal part, I guess you would call it, I just use a 3/8 swivel that I modified, and I'll show you how I did that. And that goes on here like this. Just finger tight, and then the whole thing slips into the PVC. And then the way I drilled it, I stopped the hole about right here, whatever, you know, wherever the distance of that, right there is where the hole stops. So this only goes in so far, it can't go any further. And now this thing spins freely, and I can use my thumb to steer the whole thing. To get my pan, I can use my thumb. So that's the handle. That's the part that you hold. This is the part that the camera and the handle mount to, and this also houses the weights that stabilize the whole thing. And for weights, I just use these 1/4-inch fender washers. You get these at Home Depot. I bought a whole box of these. I think there's 100 of them in a box for $10. And this is just a piece of 1/8 inch by 1 inch aluminum. It's 3 feet long. I think that costs $8.50, something like that. And I got a foot of 1/4 20 all thread to mount the weights to. And you can see how I affix the weights. I just made like different size weight bundles, and they're just bolted to the body of the thing. And then depending on what camera I use, it's going to depend on where it mounts. Optimally, you want the camera and the handle to line up directly with the weight that's underneath it. But that might change based on the camera. So you want the lens of the camera to line up with the weight underneath it, so that the eye of the camera is always on the pivot. Does that make sense? Anyway, I hope it does. Now, as far as the gimbal part of it, I used a ratchet or a socket swivel that you would find in most toolboxes in America. I hate these things because they always seem to not work when you need them to. But and I've got a few of these in my toolbox, and I never use these kind. I use the kind that come with the air tools. They seem to be a little more stable. But if you notice, that kind of just sticks in whatever, axis that you put it in, and that's great if you got a socket hanging on there. It allows you to keep the socket in line with the fastener that you're trying to get out. It doesn't work so good when you're trying to stabilize a camera. And how that's done, if you look really close, I don't know if you can see it, but there's a spring between that block right there. There's a spring between the block and this pivot. And all you got to do is drive those axle pins out and throw the spring away. And when you do that, you're left with a floppy three-way, right? So then after I got that accomplished, what it is, I chuck this in a vise and I cut the male end off flush. Just cut it off, throw that in the garbage. Center punch it, drilled it, tapped it with the 5/16. I think the pitch is 18 threads per inch. 5/16, 18, whatever the pitch of that bolt was. And then on this, not this, this is a 1/2 inch, but on the 3/8 inch square on the female end, I took a 1/4 20 bolt and I squared off the hex so it fit in that 3/8 hole. And while I had this thing apart, I welded that bolt in from the back side. You don't need to weld it in. You could use epoxy and you would accomplish the same thing. So that ends up being your gimbal. That's the part that everything mounts to. The all thread gets cut into 1.5 to 2 inch lengths, and in my example, the all thread stays on the steady rest, and you can take this nut off and add and subtract weights as needed. Or you could set this thing up so that you have packages of weights weighing varying amounts, and you can stack them, whatever. I might drill a couple more holes here and do it that way to add weight on this incline. But that's the whole thing. It's a pretty simple thing, really. Take the handle. Now I know that this hole is the hole that I need for my GoPro, and when you bolt this thing in, you want the axle of the swivel to be in line or perpendicular to this axis. You don't want to have this thing turn kittywampus like that. To me, it seems like it's a less effective way for the whole thing to move, because this isn't a true universal joint. It's kind of a hybrid universal joint. So I line that up with that axis, put a 1/4 20 nut on here and tighten that down. Got another nut here. This is the jam nut for the camera. I have my homemade tripod mount. It's just the mount that came with the camera, the big ugly square one that the camera's mounted on when you buy the thing. Just modified that and glued a piece of steel on there. You can figure that out, it's easy enough. So you thread that on there. Most cameras use a 1/4-20 for a mount. That way's front. Okay. So there you go. There's your Steadicam. And I can use my thumb to steer it. Or I can use both thumbs, a thumb and a finger, to steer it. Pretty cool, huh? So if I want to shoot uphill, I would add weight back here. If I wanted to shoot downhill, I'd add weight here. And when I'm walking, I want to walk as you know, as calmly as I can. But even walking as softly as you can with the camera that you're watching me on right now. I tried doing that when I first got the camera, and it looks like a flipping earthquake. And there's no image stabilization in that camera, or in these for that matter. So this is a really inexpensive way to get a little bit of stability in your images. And I think I'm into this for, if you don't include the drill bit, which I'm not going to include, that's $17 in and of itself. But I think I got $17 into this. I think it's a pretty good deal. So that's my interpretation of a plethora of different Steadicam mounts that are available to view on YouTube and the interwebs. I'd encourage you to find a design that you like and get out in your garage and start tinkering. If you can build it, why buy it? That's my philosophy. If you like what you see, give me a thumbs up. If you didn't like what you saw, give me a thumbs down. Rate, comment, and subscribe. I think I might put another one of these together. I got enough spare parts left over to build another one. I might build another one and maybe give it away to my, 50th subscriber or something, or maybe my 100th subscriber. So, yeah. So until next time, hey, have a great weekend, and we'll see you in the next one.
Bye.
Test shot, homemade Steadicam. Test shot 2, no Steadicam handheld.